So now we come to a totally different topic, but again on a futuristic note, a talk by Aditya Khakse on a futuristic subject of how Hyperloop technologies will help India develop. The moderator for this session is Ajay Singh. Ajay Singh is a rail enthusiast who was with the Indian Railways as a mechanical engineer for over 30 years. He has worked across the country with the Indian Railways in various roles, including a posting in the Ministry of Railways as a director. He has recently retired voluntarily from the Indian Railways to pursue his passion in the domain of water. He is an active photographer, naturalist, and writer. His photographs have featured in several publications, including as a book cover. He is a life member of the Indian Steam Railway Society and one of the founder members of the Rail Enthusiast Society. Over to you, Ajay.
Thank you, Manoj sir. After this accelerating journey to China, let's get back to India. We are at the last presentation for the day one of the conference, and we have with us Aditya Thakse, perhaps the youngest speakers in this conference. Aditya is an alumnus of the founding batch of the Gati Shakti Vishwavidyalaya. It was earlier called National Rail uh, and Transportation Institute under the Ministry of Railways. It is the only institute globally focused on rail and transportation business. He is going to share with us the Indian initiative on Hyperloop technology by TUTR Hyperloop, a technology setup based out of IIT Chennai. He is currently spearheading the business development vertical at TUTR Hyperloop while also managing key government, international, and corporate relations. Aditya's professional journey reflects his dedication to advance sustainable and scalable transportation systems, contributing significantly to the future of mobility innovation. So perhaps here lies the answer in a small but significant way to what we can do vis-a-vis China. India's vision over the next 2 decades aim for a developed self-reliant nation with world-class and efficient transportation system. It will play a crucial role in the logistics sector. With India leading global hyperloop efficiency development, the this technology will drive self-sufficiency, positioning India as a future-ready logistics powerhouse and accelerating its journey towards dropping the tag of being a developing country in the foreseeable future. So, Aditya, you are doing a very inspirational work. We'd like you to start your presentation and share your journey of TUTR Hyperloop with all of us. Over to you, Aditya.
Um, Good evening, everyone. I hope I'm audible, Ajay ji. Just
Yes, you
confirm.
are audible.
Yeah.
Okay, perfect. So I would like to take that as a compliment that I'm the youngest speaker in this whole lot. Let me quickly introduce myself as what Ajay ji told that myself Aditya Kakse. I had the business development at Tutor Hyperloop here. So I'll just go on a short background on how we started, what we are doing, and how this whole journey started. So it was around 2016 that Elon Musk started hosting competitions in US on Hyperloop and all. And the IIT Madras student team Avishkar Hyperloop started participating in the competition in the US and around Europe. Since the time, they've been winning awards and bringing laurels to the country. In 2022, the investors who were investing in this initiative started asking, what next? Are you just going to keep participating in the competitions, or are you just going to, uh, like keep it on a student level? Then the director of IIT Madras and the profs came together, and Tutor Hyperloop Private Limited was incorporated as a deep tech incubated startup at IIT Madras. And since 2022, the engineers have been working on the technology on building the linear propulsion, magnetic levitation, and strengthening the vacuum strength of the pod that we are building here. Can we go to the previous slide? Okay. So our aim was to deliver safe, affordable, and convenient on-demand transport that is good for the planet and for the pocket. One key decision that we took before going into this journey was that we'll initially start with the focus on cargo, and then eventually we'll move to passenger. And that's how initially we started with a team of 15 full-time engineers. Now, as we are growing up, we have reached with a full-time team of 25 engineers and around 10 part-time members and interns. We have industry experts who, on weekends after their job, they come to Chennai, spend their Saturday and Sunday with the team, and then fly back to their work location on Monday. We have veterans from across the industry, from Mahindra, Ashok Leyland's, government organizations. Um, we have one such expert from industry, from BARC, and there are a lot of people who have been helping us. We are gracious to them along with the industry partners. Now I'd like to talk about the founding team. So there we had three co-founders. Dr. Arvind Bharadwaj, who was formerly the Chief Technology Officer at Mahindra and Mahindra. He took a sabbatical and he joined here. We have Professor Satya Chakravarti, who is a professor of aerospace engineering here at IIT Madras, who is also a parallel entrepreneur. He has other startups like E-Plane Company, Agnikul, Aristovelos. E-Plane Company is working on air taxi, which just got a $1 billion contract. Agnikul is working on 3D printed space rockets, which also launched their first rocket last year. And Dr. Balaji Rangachari, who again was a SVP in Mahindra, came to from the industry to work on the Hyperloop segment. Next slide. So as for now, what the progress was, we have built a vacuum tube of 410 meters at the IIT Madras Discovery Campus, which was built with the gracious help of Indian Railways, ArcelorMittal, L&T, ANSYS, Dassault, and other industry partners. Everyone came together, and this can be termed as a very great example of industry-academia collaboration. This is deemed to be world's largest facility, with the Indian Railways sanctioning a revised grant of $1 million, and the length of this tube will be extended till 450 meters. So what happened was, after 410 meters, when it was sanctioned, we did not realize there was a lake after that. Now that L&T has taken over the construction, they are going to build the remaining 40 meters, which will make us the longest in the world. Tutor Hyperloop has worked on a 1.5-ton pod, which is capable of linear propulsion, magnetic levitation, and also under vacuum conditions. We are aiming to go up to 150 kilometers per hour in the tube. Okay. Now the tube is deemed to be inaugurated by the Honorable Prime Minister shortly, once we are confirmed with all the technologies that we have mastered here. And one such key thing is that comparing it to the West, we have significantly reduced the cost of construction of the tube. Here coming again with the point, saying the initial capital cost of such infrastructure is termed to be very high. Yeah, you can see the pictures here. Like be it metro, be it any high, be it bullet train, the infrastructure cost is something which we have taken a very keen R&D role on. We have made sure that the infrastructure remain passive and all the technology is transferred to the pod, hence reducing the infrastructure costs drastically. That is what we have done, and we have also patented it. So we have reduced the thickness of the tube, which West has is 16 mm. We have reduced it to 6 mm, again reducing the steel cost. So you can see how this was done. Now this was our first gen pod. Now we are on our 6th gen pod. This was our first gen pod during the initial testing in the tube, where we did linear propulsion on, completely made in India with a 1.5-ton Ashok Leyland chassis. On the right side, you can see the 30-meter track at IIT Madras, and on the left side, you can see the tube where the testing and trials are currently going on. So the base has completely shifted to the tube, where now the final testing is going on. Next slide. So we had a number of collaborations as we started this journey. So the initial one was with Tata Steel, who our journey started with, and then slowly we have also collaborated with other Hyperloop companies around the globe, and with the gracious help of the Government of India. We also tied up with L&T. We recently tied up with Sistra. We have tied up with Technical University Munich. That is how we are, making this a consortium approach. We don't want to go alone in this, because this is whole lot of a coal where a lot of efforts are required. So we are taking a consortium approach in this. ArcelorMittal has been graciously supporting us in this journey, and as along with Dassault and ANSYS. So industry partners are also coming together along with academia to drive this together. Next slide. So these are some of the recent media coverages that Tutor got. I'm sure the recent tweet by on the railway minister again amplified this, and again you would have seen a lot of media coverage. The funny thing was, we also saw some routes which were not even thought of. Recently, the day before yesterday, I came across an article. Someone was saying that a route has been planned between Tata and Ranchi in Jharkhand. People have been texting us, how are you planning this route? When are you planning this route? This is all of a media hype on the routes. We officially are currently focusing on cargo, and eventually we'll move on to passenger. Okay, next slide. So, like we said, the epicenter of Hyperloop started from US, then it moved to Europe, currently, which is in Europe. Now, along with Indian Railways, IIT Madras, what we thought was we'll shift this focus on India. Hence, last year, the Global Hyperloop competition was announced in a global Hyperloop conference where the academia, industry, government, and everyone participated. And this year, between 21st February to 25th February, a global Hyperloop competition was held at IIT Madras, Asia's first such, hence marking a shift of technology from Europe to India. Next. So these are three key areas of Hyperloop technologies which we are focusing on: linear propulsion, magnetic levitation, and vacuum. The first two are not new. These are somewhere running in the world. Linear propulsion, there are around 11 to 12 countries where linear propelled metros are running. Magnetic levitation is something which we all are, have studied about. The third is vacuum, where we are working on along with the aviation experts here, because the similarities for the structure design are almost similar. So these are three key component technology which we are focusing on, and we are focusing on a phase we earn while we learn. So we are not just doing R&D, we are also doing application-based identification on how do we deploy this technology in the current railway system. So linear induction motor is one such thing which we sort of, that this can be a good use case in mountain railways. This can be a good use case in metros, because like the less the moving parts, the less the maintenance. So this will drive down the maintenance cost. This will enhance the operation, and again, speed. So with linear propulsion, we can go up to 200 kilometers per hour, 0 to 200. With maglev, we can go up to 400 kilometers per hour. And if we need vacuum, then we can go up to more than 400 to 600 kilometers per hour. That is how we have divided these technologies. Next. So like I was talking, some potential applications for the linear induction motor and maglev. If we do not go for vacuum is not necessary. We can add it up if we want up more than 400, 500 kilometers per hour. But a thing about India is anything around 200 or about 200, we can consider is at high speed, because we don't have that infrastructure yet. So our current focus was on ports, airports, and other key areas where we could have implemented these technologies to increase the efficiency, turnaround time, and speed of the supply chain. Let's say a container has to be evacuated from the port to a container yard, which is 8 kilometers from the port. The linear induction motor based automated system can do it within 5 minutes. Like let's say, there are a lot of greenfield airports coming up in the countries and which are far from the city. Jewar at Noida, Navi Mumbai, and Parandur in Chennai. So these have distance of around between 30 to 50 kilometers from the existing airport. What if the government wants to make this as one single airport? So we actually connect the two airports with linear induction motor and maglev based corridor. And good thing is the same infrastructure is the same infrastructure is scalable. Sorry. So the good thing is the same infrastructure is scalable. So I need not to create new infrastructure for each technology. So I can scale the same infrastructure I have if I have mastered my LIM to maglev and from maglev to vacuum. So these are some potential use cases. Next. So again, like I do not need to say these are some uh, advantages of having Hyperloop technologies. And this I'm not just talking specifically about the full-scale Hyperloop stack, which consists of vacuum, maglev, and LIM. These are the advantages of all three stack of Hyperloop technology when I talk about linear induction motor, maglev, and Hyperloop. Next slide. So this is the global Hyperloop map as such. You see the industry started in around US. Now there is a lot of work going on around Europe, and good thing is we have tied up with most of the European Hyperloop companies. And within India, we don't have as such more information about China, but there is work going on in Korea, and we are working on in India. So this we have made a thing since there is no standardization of Hyperloop tracks and Hyperloop across the world. We have taken this on ourselves along with Indian Railways that we will standardize this. There is how do I say, there is a constant mindset that what West does, we follow. Whatever West does, whatever standards West sets, we'll follow that. We have taken upon ourselves that we will set a standard for this one and let the rest of the world follow. Because we have the technology here, we have the resources here, we have all the backing here, we have potential use cases here. For Europe to prove anything on a Hyperloop, they have to go of 400 and 500 kilometers per hour because they already have trains running at around 350, 400 kilometers per hour. For us, if we start with linear induction motor, we start with 200 kilometer per hour, we scale it to 300, 400, 500, then eventually, if required, 600. So that brings us the market. We have the resources here, all IITians, all from top colleges of India, students working here. So it's a complete landscape, and most of all, the industry is backing us full time. So we have a full stack backing along with the resources that are required. So this time, this is something which we have taken at when we are proud to take this up, that we set the standards and rest of the world follows this. Next slide. So like I said, for some potential use cases, ports was a potential use case that we found. Like most of the ports, the city has grown around the port. So how do you evacuate the containers from the port to the inland container yard? There is also difficulty of congestion in the port, too many trucks. The government is aiming for net zero emissions. How do you achieve when there are so many trucks in the port causing congestion on taking out the goods? So what we thought was, why not we automate the port or the container yard? The container will reach the gate and the truck will take it outside from the gate itself. No need for the truck to enter the port. So these are some potential areas that we identified. Next. So I think this will be my last slide. So there is one key question which a lot of people asked us: why are you different from Virgin Hyperloop? Hyperloop One, which came in the industry some year back and had a lot of backing from Elon Musk, Richard Branson, and other people. If a company with such a huge backing failed, why do you think you will succeed? So we have a very fundamental difference from Virgin Hyperloop. You see, they targeted high-speed corridors with direct focus on passenger first. Later, after burning a significant amount of money, they thought that no, we will go to cargo. That's when Richard Branson backed out, and they didn't have this focus on modularization of the technology. And like I said, if we go on passenger with this high amount of speed, regulatory issues, safety issues, a lot of issues come together. What we have differentiated from Virgin is we have modularized the technology. I am not saying that I'll directly achieve 600. I will start with 200, then I'll go up to 400, then I will eventually achieve 600. And by the time I achieve 600, I would have my learnings, which I can implement on the safety and regulatory parameters. And starting with cargo gives me that edge. Like if I start with passenger, it is a complete regulatory and safety compliance issue. But if I start with cargo, those issues are less. And by the time I reach that phase where I have to turn this technology implementation from cargo to passenger, I would have learned a lot of things. I would have had a lot of learnings in the terms of research and development, which I learned from my cargo operations. This second. India has a frugal engineering approach. It means whatever we do, we have that cost-effective mindset from the Europe. Like I told you, the infrastructure that we build it almost on less than half of the cost of what the West has built it. So again, that is something that is different from us. And the modularized technology approach. I have use cases for all three technologies: linear propulsion, maglev, and vacuum. They just focused on vacuum. So yeah, these are some of the differences that we have with Virgin Hyperloop. And yeah, I think that is the last slide. So can you go? So that is how I close my session. I would be open to questions now. I think there are some questions in the chat.
Thank you, Aditya, for that quick, very quick, but very, very impressive, introduction to what is being done in India. And I think there is something in the air of Chennai. Train 18 has also come out, and I have a feeling that, the actual Hyperloop on the ground will also come out of Chennai only. And it's so nice to see that a very comprehensive ecosystem is being developed, which is very much a requirement for a complex industry like railways or transportation system. And and you have taken a very practical approach of first going for cargo, and then as the things develop, go for passenger traffic. So people are hungrily waiting for your product to come out. Even people in Tata and Ranchi are looking forward for your after you finish your cargo, then you go to passenger, and they're already asking for that. So best wishes to you. One technical question comes to my mind before I go to the chat box, is that in this, everything is being tried upon currently for a linear route, but later at some stage you'll have to have a routing, junctions and other things. So are you simultaneously working on that, or is it on back burner at this moment? Because
No.
you'll have to have a point where, like in railway parlance, we have a point for going to different routes.
Hmm. Yeah, actually, we are parallelly simultaneously working on that. But for now, our key focus remains on demonstrating the technology which no one in the world has. So, like I talked about the technology part. Apart from that, like I told you, we scaled up the team. So we have teams working on multiple domains and multiple research areas. So yes, that is definitely one such thing which we are working on.
Okay, now I'll take some questions from the chat box. Mr. Suri wants a very specific date. When do you hope to have a trial with the passenger carrying pod?
We hope that day comes very soon. We are having some plans of setting up a test facility for
Okay.
testing and trial of the pods carrying a passenger. So right now, the tube that we are working on is a 2-meter dia, which is not that convenient to have a passenger trial on. It can be convenient if we make that, but we don't want to. We want to keep it in subscale. We are planning to have a tube with 5-meter dia, which can accommodate a container as well as a passenger pod. So that is one such area which we are working on. Hopefully, we have a timeline of around 24 months deadline, which we have kept within ourselves to have that first trial going on for passenger.
It's absolutely amazing to hear a timeline in months. Best wishes to you.
Thank you.
We seem to have a structural engineer amongst us. He's asking a very, very specific question. How is safety maintained when the thickness of the Hyperloop tube is reduced from 16 mm to 6 mm?
Okay. So there are two aspects to this. As you must have all have seen the pictures of, there are pylons and then there is a tube. So this design is structured in a way that the weight is concentrated on the tube, thus reducing the weightage on the steel thing. So there is a company in Netherlands, Hart Hyperloop. They have the track up on the up. Their pod, like we have a track on the pylon on the ground. Their track is upside, hence again taking the load on the tube. Similarly, there are other European Hyperloop companies who are working, who have massively, put the weight of some components on the tube. We have put it right on the pylon, thus making the necessary of tube to be 60 mm lesser.
Aditya, basically, when we talk about Hyperloop, we think about speeds of almost 1000 kmph.
Hmm.
But what I see is that you are planning to go up to 600.
Hmm.
When you go to 1000, will it make a difference whether you have a 16 thickness tube or 6 tube?
No, it won't, because again, like I said, we have kept the infrastructure passive. If I talk in layman terms, we have worked on the car, we have not worked on the road.
Okay. Now, Hemo is there. He's asking specifically about the fact that high speed will make sense when you have longer distances. Just by connecting airports or port connectivity, it may not make sense because it will not help in crushing the time much. So this
Yes.
is his viewpoint. Any comments on that?
Yes. So, like I said, India is a very, you know, different market from the rest of the world. So here, if you make a business case, that should make sense to the public. We have
Okay.
bullet trains, we have other high-speed trains now. If I introduce something up to 400, which has a speed of 400, let's say 600, 800 kilometers per hour, there should be users for it, and that market has to be studied well. For now, I have users among the applications that we have identified:
Okay.
ports, logistics, airports, connecting airports. These are some issues which we are not in a we are not making a solution in search of a problem. We have
Okay.
a problem and we are making solution for that.
I think that makes sense because it will help you in funding also.
Yes. And again, like I said, our eventual goal is to go there. But if I directly jump there, I'm missing 6 steps on the way, which if I fall, I will fall directly on the first step.
All right. So Mr. Suri again asked the question related to speed, which is Hyperloop is supposed to run pods at a speed in excess of 1000 kmph. Will TOTR ultimately aim to achieve this speed?
Yes. Yes. So, like I said, we are taking one step at a time. We start with linear propulsion, then we go to magnetic levitation, and after we have mastered maglev, we will go to vacuum, which can take up to a speed of more than 1000 kilometers per hour. So yes.
Okay, so we have Atulya Sinha, who's one of our team members in the organizing committee. He's thanking you for keeping us in loop. And I think one last question I will take from Kaushik Dharwadkar. You are making Hyperloop, and Mr. Kaushik happens to be our hyper active member in our Rail Enthusiast Society community. And he's a very technically oriented guy, and he's asked a very long question. Let me see if I can put it
No,
through to you.
I have actually summarized the question. I have read it, so I'll just give it a
Thanks for
yeah.
taking my role also.
So I think I'll give it a very quick answer. So
Okay.
when I talk about implementing Hyperloop, I don't see it as implementing the tube with vacuum. See, that is what comes into everyone's mind when I talk about Hyperloop.
Yes.
There will be a
Yes.
tube, there will be a pod running at extremely high speeds. Like I said, we have modularized the technology. When I talk about freight and mountain railways, I start with linear induction motor, which is currently running in the world, and that doesn't need a tube. That needs a track which we have designed, and as of on Hyperloop perspective, with the same track
Okay.
can be scaled up for maglev, and the same track can be scaled later. You can add a tube on the same track, so that is fine. Now coming to the next part of the question, mountainous terrain. So biggest advantage of having a linear induction motor is there is no slippage.
Okay.
So that is something which has us in the first mind. And like I said, as of now, the mountain railways are losing almost a huge chunk of money in whatever areas that they are operating. Again, when I talk about freight, if I add linear induction motor, I increase the speed of turnaround time from evacuating the container from the port to the inland area and bringing it back, thus increasing the capacity of the port. As per our calculation, we have we can increase the capacity of port by more than 20 to 30% if we implement this.
All right. Thanks a lot, Aditya, for this very insightful conversation. And it's 18:30 as per my clock. And with this, I hand over the mic to Manoj sir, take forward the proceedings and close today's session.
Thank you so much, Aditya, for a glance at the world to come, and Ajay for spearheading the session so well. And thank you, everyone, as we come to the close of today's proceedings. I'm sure that all of us who attended had an enriching and a very enlightening time. We shall meet again tomorrow at 12 hours with more interesting and exciting sessions. Thank you and good night.